Okay, this lesson is about synthetic division. We've been working with polynomials and we've add, subtract, multiply, square, cubed them, but right now we're going to learn how to divide them. And there's actually two ways to divide them, one by doing long division and one by doing synthetic division. And synthetic division doesn't work every time, but when it does, it's a little bit more efficient, a little bit quicker. It just kind of manipulates the numbers and then you add the variables back in at the end. So we're going to take a look at this and work through it. Now, when you do synthetic division, you got to look what the degree is. So on number 1, the highest exponent is a 3, so it's a degree of 3. Then you start working back down. So I've got 2x cubed. I'm going to rewrite this. So I've got 2x cubed. I have 7x squared, but I don't have an x term. And each term has to be represented. So it's not there. I'm going to call it 0x and then minus 4. And I put that 0 there because I kind of need it as a placeholder. Then for synthetic division, I'm going to start by making a little box. Now in that box is what I'm dividing by. I'm dividing by x minus 3. Well, I kind of want you to think of this as like a factor. And when we were solving by factoring, we'd set it equal to 0 and we'd get x equals positive 3. So that's what we're going to put in the box. Now next to it, we're going to put all the coefficients. 2, negative 7. We're going to include the 0 because we need it as a space holder. 2, negative 7, 0, negative 4. Right at those coefficients. The first step is we take the first number and carry it straight down. Then we simply follow a pattern. Multiply, add, multiply, add. So 2 times 3 is 6. Negative 7 times 6 is negative 1. Negative 1 times 3 is negative 3. Add those together, we get negative 3. Multiply, we get negative 9. Add them and get negative 13. Whatever number is here, this is the remainder. So now when I write it, we kind of calculated what it would be without writing the variables. Well, now we need to rewrite it back in with the variables. But when we started with 2x to the third. So when we divide by this binomial, it's going to go down a degree. So it's going to start, and I look over here, it's going to start at 2x squared because we're going down 1 degree from where we started, and then minus x minus 3. Now I need to write the remainder. So I'm going to write, starting to write the wrong number, negative 13 over whatever we divided by, and we divided by x minus 3. That's it. All right, let's do it again. Now if I look at the second one, I've got x cubed, but I'm missing x squared, then I've got x in the number. So I'm going to rewrite it this time just to make sure I don't lose track of everything. Okay. If you don't need to rewrite it, that's okay too. So in the box is what I'm dividing by. Now remember, technically you got to set it equal to 0 and solve. So what I'm dividing by is not negative 1, but positive 1. And then I have 3, got to keep my placeholder, 0 for the x squared, negative 5 for the x, and then 10. Once I've got it set up, you're going to bring the first number straight down and then multiply and add. 3 times 1 is 3. Add them together, get 3. 3 times 1 is 3. Add them together, get negative 2. Multiply, get negative 2. Add them together and get 8. So this is your remainder. So when I write my answer, because I started with x cubed, I got to start down 1 degree. So this is going to be 3x squared plus 3x minus 2, and the remainder is 8 over x minus 1. All right, let's try this again. Now as I'm looking here, it starts with x cubed, it's got a squared, it's got an x, and it's got the number. So I don't have to put in any placeholders this time. So in the box, set it equal to 0. This is going to give me positive 5, and I have 1, negative 8, 17, negative 10. First number gets carried straight down. Now I multiply. 1 times 5 is 5. Add, get negative 3. Multiply. Negative 3 times 5 is negative 15. Add, and I get 2. 2 times 5 is 10. Add, and I get 0. So the remainder is 0. So now when I write this, start as x cubed, so this is 1x squared, or just x squared, minus 3x plus 2. When the remainder is 0, you could write 0 over x minus 5, but 0 over anything is just 0. When there's no remainder, you don't have to put any fraction at the end. All right, let's try one more like this. Now this one, when we set this equal to 0, that's going to give us negative 2. Got cube squared x and then a number, so I don't have to put any fillers in. So this is 1, 5, -1, -9. The 1 comes straight down. 1 times -2 is -2. Add and get 3. Multiply, -6. Add and get -7. Multiply and get 14. Add and get 5. So this is the remainder. So now when I write it, it started as x cubed, so I go down one level, so it's going to be x squared plus 3x minus 7. This time it does have a remainder, so I write it 5 over what I divided by, which is x plus 2. Now, we have what they call a remainder theorem, and I'm not going to write it all out, but the remainder theorem when you're doing synthetic division is that if you're trying to evaluate the function, like evaluate it when x is -2 or when x is 3, then you can use synthetic division, and whatever the remainder is, that's your answer for the problem. So let's try this on number 1. Now, this time, it's already solved for x, so I don't have to do the opposite, I just do the -2. So I'm going to do the -2, and now I do my coefficients. So x to the 4th is the highest, so that's a 2. I don't have an x to the 3rd, so it's 0, so I put 0 in because I have to have that placeholder. 1, -10, and -1. So the 2 comes straight down. 2 times -2 is -4. Add and I get -4. Positive 8, add and get 9. -18, add and get -28. Multiply and get 56. Add and get 55. This right here is what you would get if you plugged in -2 and evaluated. So f of -2 is just 55. That's our answer. Okay, let's try this again for 3. So I'm going to plug in 3, and I can do that using synthetic division. Now I've got cube squared x number, so I don't have to put in any zeros for space holders. So I'm just going to have 2, -3, 4, and 13. The 2 comes straight down. 2 times 3 is 6. Add and get 3. Multiply, get 9. Add and get 13. Multiply and get 39. Add and get 52. So if I plugged 3 into this polynomial and evaluated, I would get 52. But this way, I don't know if shortcut's the right word, but it might be a quick way of getting the answer. Last one, I'm going to plug in 5. I've got cube squared x number, so I don't have to placeholder, so I'm going to have -1, 12, 6, 80. So the -1 comes straight down. Multiply and get -5. Add and get 7. Multiply and get 35. Add and get 41. Multiply and get 205. Add and get 285. So if I plugged in 5 and evaluate that function at 5, I would get 285. That's all we're doing with synthetic division.